In this video, we're going to learn about chemical equations and balancing chemical equations. A chemical reaction is a process in which one or more substances are converted into one or more different substances. So in chemistry classes, we write a chemical equation in this format where we say some sort of molecule, compound, element in a certain state reacts with another molecule, compound, or element in a state, and those react and are transformed into another compound and maybe another compound, each in their different states. So these states are states of matter, most commonly solid, liquid, gas, or, as you'll see, often aqueous, which means dissolved in water. We'll be diving into that a little bit more. On the left side are what we call the reactants. And on the right side are what we call the products. So example of this would be the combustion of methanol. We've seen methanol before, CH3OH in a liquid form can react with gaseous oxygen, diatomic oxygen, which we've seen before, and it will form carbon dioxide gas and water in liquid form. The law of conservation states that in a chemical reaction, matter is neither created or destroyed. And we're talking chemistry, we're not looking at nuclear physics or nuclear chemistry. So in this class, what this is going to tell us is that we can't change the number or types of elements. So we have to have the number of moles of the elements in the reactants as equal to the number of moles of those elements in the products. And so that means if we have one carbon atom over here, we need to have one carbon atom over here. If we have 1, 2, 3 oxygen atoms on this side, we need to have 1, 2, 3 oxygen atoms on that side. And if we have 4 hydrogen atoms on this side, we need to have, we only have 2 hydrogen atoms on this side. So that means this isn't balanced. Okay, so in order to make this reaction true, we need to balance the chemical equation so that it will adhere to the law of conservation of mass. So let's go ahead and do that. First, we'll go over the guidelines of balancing chemical equations, and then we'll go back to the example that we just used. Okay. The guidelines for balancing chemical equations are: start with atoms in the most complex substances first. Okay. We'll write out columns for reactants and products for each atom. We'll go one step at a time. We'll fix each atom or each element at a time. Okay, and then we'll always check our work. So let's go ahead and do this for the reaction that we just explored, the combustion of methanol. So we have CH3OH again, and we'll say that's in liquid form. It reacts with O2 gas, and it's going to go to CO2 gas plus water liquid. Just, whoops, that's not what I wanted to do. back. I'm going to just move this here. So what is that enough space? Maybe not. Back. There we go. So what I've done here is I've left a fair amount of space in front of each of these chemical species because we're going to change number of moles of chemical species. We are not going to change the chemicals that we're dealing with. So this is methanol, and methanol has 4 hydrogens, 1 carbon, and 1 oxygen. We cannot change any of these subscripts that come after the atoms. You do not change subscripts after the atoms. If you did that, you would be changing the chemical identity, and we're not doing that in balancing chemical equations. What we're going to be doing is changing the number of moles in order to balance the elements. So we'll start by counting the number of moles of each type of element on the reactants and product side of the equation. Reactants, we have carbon, hydrogen, and oxygen. We did this earlier. We have 1 carbon atom, we have 4 hydrogens, and we have 3 oxygens. On the products, we have 1 carbon, we have 2 hydrogens, and we have 3 oxygens. Oh, crud. My thing. I'm going to start this all over again. Anyway. We'll start by counting the number of moles of each element on the products and reactants side. So for the reactants, we have carbons, hydrogens, and oxygens. And we counted this earlier. We have 1 carbon, we have 4 hydrogens, and we have 3 oxygens. On the products side, we also have carbons, hydrogens, and oxygens. We have 1 carbon, we have 2 hydrogens, and we have 3 oxygens. So we know that we have more hydrogens on the reactant side than the product side. So we're going to fix that by saying, well, let's just give ourselves 2 moles of water. If we have 2 moles of water on the product side, we'll have 4 moles of hydrogens, and we will change our oxygens from 3 to 4 moles. So now we fixed one, but we have another problem. So now we want to go over to the reactant side and increase the number of oxygens. We'll change colors again. We'll go to green. So our first step was in blue. Our second step was in red. I'll go ahead and write this out. Just step 1, then step 2, then step 3. We'll put that in green. So now we'll say, okay, well, let's increase the number of oxygens. And why did I increase my number of oxygens here and not here? 2 reasons. 1, I want to balance the atoms in the most complex substances first. The last thing I want to do is the easiest, simplest thing, and O2 is the easiest, simplest thing I've got. And I know that just doubling by just putting a 2 there, I'm not going to fix it. I'm going to have some more steps to do. If I knew that by putting a 2 there, I would fix the whole thing, then I would go ahead and do it. But if you tried it and counted it, you'd realize that that's not going to work. So we're putting a 2 in front of the methanol. So that means, to recount, we have 2 carbons now. We have 8 hydrogens. And we should have 4 oxygens. Correct? 2, 4. Yes, now we're looking good. All right, so now we're back to having more things to change. Our carbons are off and our hydrogens are off. Step 4 is going to be saying, well, we're going to need more CO2. So we'll now have 2 carbons. We're going to not change our hydrogens, and we're going to increase our oxygens. But I know that we're going to need to double our hydrogens. So in this same step, I'm going to say that 2 is actually going to turn into a 4. So now I can say I've doubled my carbons. My hydrogens have doubled, so now I have 8. And now I have 4 oxygens over here, and I have 4 oxygens over here. So now I have 8 oxygens there. Now let's go back to red. 5th step. The only thing that needs to change are the number of oxygens, and all I need to do is double the number of oxygens here. This is where our simplest molecules come in very handy, because in order to double, going from 4 to 8, if I put a 3 in front of this oxygen, that means I'm going to have 6 moles of oxygen from this. So 3 times 2 is 6, because I have 3 moles of O2, and each mole of O2 has 2 moles of oxygen. So then that means I have 6 from here, 2 from here, that's 8. Now we're going to just do our double check. We'll do our double check in green. I draw a line, and I just go back and I do the math all again. I have 6 oxygens, and I have another 2 from there, so I have 8. And so we don't get confused, I'm going to delete these out. Great. Delete that too. I have hydrogens in methanol. I have 2 times 3. I have 6 plus another 2 there. That is 8. And carbons, I have 2 carbons. On the products side, for carbons, I just have those 2 carbons. I have 2 times 2, 4 oxygens there, and then another 4 oxygens there. That's a total of 8. And then for my hydrogens, I have 4 times 2, that is 8. I checked. I am now balanced. This is my balanced chemical equation, and we will rewrite it to make it look nice. Because I took up so much space, let's just make this a little bit smaller. There we go. And we can rewrite our whole equation. 2CH3OH liquid plus 3O2 gas goes to 2CO2 gas plus 4H2O liquid. There it is, our balanced. For practice, take a few minutes to balance the combustion reaction of octane in the presence of oxygen. It's a little more complicated, but very similar type of reaction. Please pause this video, do it on your own, answer the question, and then we'll come back and do it all together. Welcome back. So we are here to balance the combustion reaction of octane. We're going to start by writing out reactants and products. We have carbon, hydrogen, and oxygen. On the left side, we have 8 carbon, we have 18 hydrogen, and we have 2 oxygen. On the right side, we have the same elements, and we have 1 carbon, we have 2 hydrogen, and 3 oxygen. So, I'm going to rewrite the reaction out below to give us space to edit it. C8H8 18 liquid plus O2 gas goes to CO2 gas plus H2O gas. Now we need a lot more carbons on the right side. In fact, I'm going to need at least 8. So let's go ahead and put an 8 there in front of CO2. And I can look at this and say, I also am going to need a lot more hydrogens on the products side. So we're going to just do that at the same time. I'm going to need double, I'm going to need 18 hydrogens, and I have 2. So if I have 9 H2O molecules, then that means I'll get 18. So this is my first step. I'm doing 2 things at once. But I know that I'm going to need to do both of these and probably more. So I'm going to now figure out what I've got for carbons, hydrogen, and oxygen on the product side. After this, I will have 8 carbons. For hydrogens, I'm just going to have 18. And then oxygens, I should have 25. 8 times 2, so that's 16, plus 9, that should be 25 oxygens. So now our next step, we think about going over to the reactant side and changing the number of oxygens. Can we do that? Can we just change the number of oxygens here to get to 25? No, because this has got to be an even number of oxygens. You see that? We have to have an oxygens in multiples of 2. So that tells me that I actually need to go back to the right side of the equation and make some changes here, because I won't ever be able to get 25 oxygens on the reactant side. So we'll do in red step 2. There are a variety of ways to tackle this. I am going to propose that what we do is double everything. Now, that might mean we're going to overshoot, and if we do overshoot, we can go back and divide by a common denominator. But if we double everything, and we say this is 16, and this is 18, well, I know I'm going to be doubling my number of oxygens, and therefore I should end up with 50, which then is a multiple of 2. Okay. So this is the technique that I'm going to use, which usually makes it go a little bit faster. So now I'm said, okay, now on the product side, I'm going to have 16 carbons. I'm going to have double the hydrogens, 36, and I'll have double the oxygens. I'm going to have 50. Whew. Okay, so now I know that I should have a multiple of 2 for the oxygen, so I should be able to fix that, but we're not going to go there yet because this is the simplest and we want to go complex to simple. Okay, so let's look at the carbons. I need to double my carbons on this side. So if I put a 2, oops, let's use another color. So that's our step 3. I need to double my carbons. So we're going to go ahead and say, oh, what am I thinking? 2 there to double my carbons. And that should get us to 16 carbons. But now it's also changed our hydrogens. It's doubled our hydrogens. That's going to get us to, oh, hey, look at that, 36. Ah, now we're talking about something really good. We have the correct number of carbons, the correct number of hydrogens, and the only thing we need to change are our oxygens, and 50 here is a multiple of 2, so the last thing we're going to do is balance our oxygens. We're just going to put 25 there. 25 times 2 is 50. So now get rid of that, and we should have 50. Let's check. We have 2 times 8, that should be 16. Then we have 2 times 18, that should be 36. We have 25 times 2, that should be 50. On the product side, we have 16 carbons times 1, that's 16. We have 16 times 2 oxygens plus 18 oxygens. That should be 50 oxygens total. And then for hydrogens, we have 18 times 2, that should be 36. Okay, so that's all correct. The last thing we need to do when we're talking about these really big numbers, and I alluded to this earlier, is making sure that we can't divide by any common denominator, because that wouldn't be, it would be a balanced equation, but it wouldn't be the simplest balanced equation, which is what I'm going to be asking you to provide me. So, could we divide by 2? Nope, because if we divided by 25 by 2, we wouldn't have a whole number. We can't divide by 3 because 2 is smaller than 3, so we've already established that these are the smallest values that we can get for having a balanced chemical equation. So we are done with this, and let's rewrite it. 2C8H18 liquid plus 25 O2 gas goes to 16 CO2 gas plus 18 H2O gas. We are done.